Okay, so we're taking a look at 6.1 and probably 6.2 before break. So 6.1 is about the periodic table and its development and all the people that were contributors. So we've got a German scientist by the name of Johann Dobrinner, and he was the one that noticed that some of the groups of elements like chlorine, bromine, and iodine had similarities. He called them the triads. And this led to there being some evidence that the elements could possibly be organized in a certain way. Then we've got an English chemist, William Oldling, proposed that elements could be divided into groups based upon chemical and physical properties. And a lot of the groups that he had actually resemble some of the groups that we have today. And then we've got a French geologist that arranged the elements according to an increasing atomic mass. When he did that, he noted that some of the elements had properties that reoccurred. And so he came up with this graph that kind of looked like a cylinder. And he published a paper, but he didn't include the graph. So a lot of chemists actually ignored his work. And then we've got an English chemist, John Newlands, that noticed that similar properties repeat every eighth element, just like the notes on a musical scale repeat every eighth note. And Newland called this the law of octaves. Okay? Let me know when I can move this page up. Okay. The most successful organization of the elements came independently by two, pretty much the same time, by a couple of different chemists. The first one was Meyer. The second one was Mendeleev. Now, Mendeleev was ultimately awarded most of the credit, and I'll tell you why. In 1869, Mendeleev had submitted a paper, and he had arranged the elements into a table and proposed something called the periodic law. Let's take a look at the next page. So if you arrange the elements in order of increasing atomic mass, you'll see a pattern where properties reoccur on a regular basis. And the reason why Dmitri Mendeleev received most of the credit for organizing the first successful periodic table is because Mendeleev's work was published a year before Meyer's. Number two, Mendeleev concentrated on chemical properties. Meyer focused on physical properties. And then third, Mendeleev left blanks in the table where he predicted elements that hadn't been discovered yet would eventually be placed, and he was pretty darn accurate, hence the reason Mendeleev received most of the credit. His periodic table is similar to the one that you see in the middle of your book. Okay, and we're going to take a look at the next page. Let's come down here to the modern periodic table. Since the late 1800s, a lot of modifications have happened to elements that were discovered and the periodic table being reordered. So Henry Moseley was a British chemist, and he had reordered elements according to atomic numbers rather than atomic masses. So if the elements are arranged in order of atomic number, you'll also see a pattern where similar properties like atomic radius, electronegativity, ionization energy reoccur on a regular basis. So let's take a look at the top of the next page. And we're going to go over a few terms that go with the modern periodic table. So we've got the horizontal rows, which are called periods. They are numbered from the top down 1 through 7. You guys have already labeled them as n equals 1 through 7. And then we've got the vertical columns, which we call families or groups. Now, these are labeled in one of two ways. There is an older system, which assigns the number 1 through 8 with either the letters A or B. The periodic table on the wall has those numbers and the letters A or B after them. They're Roman numerals with the letters A and B. On your nomenclature periodic table, you've also got that, okay? I'll go over what the A and the B mean in a second. The more modern system, which is something that all chemists throughout the world use because it's governed by the International Union of Pure and Applied Chemistry, which is known as IUPAC. We now use the numbers 1 through 18, and we don't use any letters. Okay, so that is on the wall. That's also on your atomic mass periodic table that you've got in front of you. Okay, a couple of things that are really important to know about the periodic table. Number one, elements that are in the same family. That means the same group or the same column. They have similar chemical properties. So that means if you're looking at the first group, which would be group number 1 or 1A, lithium, sodium, potassium, rubidium, and cesium all have similar properties. The reason is because they all have similar outer electron configurations. They all end with an S1. So they all have one valence electron, okay? Now, the other thing you should know is that as you move down a group or across a period, you're going to notice that there are some properties that change regularly. Like you can predict whether they're going to increase or decrease. I'll talk about these things. These are things like metallic character, atomic radius, ionization energy, electronegativity, okay? Now, some of the groups have distinct names, or some of the periods have names. So all of the groups 1 and 2 on the left, and then 13 through 18 on the right. These are known as representative or main group elements. If you take a look at this periodic table here, they've already labeled the representative elements for you. On the older periodic table on the wall, and on your nomenclature periodic table, you will notice that the old numbering system with the numbers 1 through 8 and the A's and the B's, anything with an A above it is a representative or main group element. So this is 1A and 2A. Everything in the middle is a B. And then this would be 3A, 4A, 5A, 6A, 7A, and 8A, okay? All right, then you've got the transition elements in the middle. These are often called the transition metals. And then we've got the inner transitions. So the inner transitions are the 2 rows underneath the periodic table that are detached. So if you come down here, these are your inner transition elements. And each row within the inner transition elements has a specific name. So let me explain why. This first row is called the lanthanides because they follow the element lanthanum. The second row is called the actinides because they follow the element actinium. Okay. Can I go to the next page? Okay. On the next page, they talk about the different properties of the metals, nonmetals, and metalloids. Okay, so I will definitely ask you as we move along, like I will ask you a question on a test about every single one of these, like which one of the following is a representative element, which one is an inner transition element, what is the name of one of the rows of the inner transition elements, do you know what I'm saying? So on the next page, when they talk about the different properties of the elements, I will definitely ask you about these. So let's go over the properties of metals first. So metals tend to be solids at room temperature. We know that because if you take a look at the periodic table on the wall, the symbols for the metals tend to be black. So black symbols identify those substances as solids at room temperature. And then the only one that isn't would be mercury. Mercury is a liquid, and you can tell because mercury's symbol is blue. Generally speaking, metals are shiny or they have a pretty metallic luster when you freshly cut them or polish them. They're awesome conductors of heat and electricity. They are malleable. You should know what this term means. Malleable means I can hammer it or roll it into thin sheets. And then you should also know the word ductile. Ductile means that they can be rolled or stretched into wires. Okay, so we've got aluminum foil, which would be malleable. And then we've got copper wire, which is ductile. Both are metals, okay? During chemical reactions, metals love to give up their valence electrons and they form cations. You know this because we've been using metals in nomenclature as strictly positively charged ions, okay? And then the nonmetals, which are in the upper right-hand corner, their properties would include, they are generally gases, because if you take a look at the periodic table, most of them have red symbols on the periodic table. And then some of them are brittle if they're solid. So you've got a couple of black symbols on the periodic table. The only one that is a liquid would be bromine. They range in appearance. They can be dull, they can be lustrous, they can be translucent or opaque, and they are terrible conductors of electricity. During chemical reactions, they tend to gain electrons because they're desperately trying to fill their valence shell. They only need like 1, 2, or 3 more electrons. That's why they tend to form anions, so they all have negative charges. And then sometimes when they form bonds, what they're going to do is they're going to share their valence electrons with nonmetals, which I'll talk about in a later section, okay? Then we can move along to metalloids. So the third category of elements on your periodic table would be the metalloids. Metalloids fall along that darkened stair step. They're also called semimetals. They have listed all of them here. And these solid metalloids are also semiconductors. What that means is they're actually terrible at conducting at room temperature, but they become better conductors as they heat up, okay? So this is the opposite of how metals conduct. Metal conductivity actually varies with temperature. Metals become less conductive when the temperature goes up, okay? Now, within this section right here, this is where I'm going to talk about the first periodic trend known as metallic character. So periodic trends are the trends that we can predict whether they're increasing or decreasing based upon our location on the periodic table. Okay, so this is the first periodic trend that I'm teaching you. And generally speaking, if you're looking at the periodic table, metallic character will increase as you move to the left and down. And this makes sense because the nonmetals are in the upper right-hand corner and the metals are over to the left and down. So as you move closer to the metals, metallic character would be increasing. Okay, so the kind of question that I would ask you is I would ask you to compare like 2 different elements. So let's say you've got chlorine over here and we've got francium down here. Obviously, francium would be the more metallic character because of its location, okay? Okay, let's turn the page and let's talk about some of the group properties and then we're pretty much done.